Today I want to talk about VWFA. No, I'm not referring to Vikings who feel ambivalent, although that has to be tough. I'm sure just like the rest of us, some mornings they get up, it's cold, they put on their horn helmet, they just don't feel like exploring and pillaging. No, the VWFA that I'm talking about is the visual word form area. The visual word form area is a patch of cortex that's specialized for the visual processing of letter string sequences, also known as printed words, that's located in most people in the posterior part of the left side of the brain. It plays a big role in reading, and specifically, it helps reading become fast and automatic, so the brain can connect the appearance of words to their sounds and their meanings. Or as Cletus put it,
"It's that youngin' what sorts them squiggles into words."
That's right, it's a squiggle speed sorter. Unlike some other functional brain areas, not everyone has a VWFA. Only expert readers have one. This cortical area forms when a region of the brain that's already good at processing things like oriented lines at the center of vision becomes even more specialized because it receives a whole bunch of squiggle inputs. In this case, through lots and lots of time spent looking at printed letter strings. So let's get into an extended groove on the VWFA. Let's have some 3-pound thoughts. Okay, I want to organize today's talk in the following way. Although we're talking about a bona fide patch of brain tissue, I want to spend most of this session talking about the cognitive science of word recognition without really worrying about brain anatomy or physiology. I want you to test yourself and the functioning of your VWFA. I'll do this by walking you through a series of demonstrations on word recognition, which are actually pretty fun, and they demonstrate the concept of automaticity really well. After we do these demos, which I hope will really get you thinking about what your VWFA does, I'll talk a little bit more broadly. I think learning about the visual word form area is an excellent introduction to understanding more about how brains work in general. It's the perfect neurodevelopmental framework for thinking about learning, brain development, and cognitive neuroscience more broadly. Okay, let's do some demos. Get comfortable. The first word recognition demo I want you to do is related to something called the Stroop effect. Some people may be familiar with this. The beautiful thing about Stroop effects is even if you know all about them and you know what to expect, you still can't stop them from happening. We'll start with simple reading and then we'll work our way up to the Stroop task itself. Right now you see a matrix of words with rows and columns, and each word names a color. What I want you to do here is choose any 2 rows in this matrix. You'll see each row has 10 words in it, so I want you to read at least 20 words going from left to right for each row you choose. Don't start this yet though. After you've chosen which 2 rows to read all 20 words in those 2 rows out loud as quickly as you can without making any mistakes. If you make mistakes, start all over again. And I want you to time this so you get a precise measure of how many seconds this takes you. If you're a real trooper, or I guess in this case a real strooper, you can choose to read more than 2 rows or even all 5 rows, which is 50 words, and then time the whole thing. The more rows you read, the more obvious the Stroop effects are going to be as we continue along in these tasks. So this task right here is going to give you a baseline time for all your subsequent tasks that I have you do for comparison. So try really hard to do this as fast as you can, but without making any mistakes to get a good, reliable baseline measure. And then the other thing to remember is remember the location of the rows that you read here, and then make sure you read the same exact rows in the next tasks that we do that'll follow. So if you read all 50 words, you have to read all of them again for the following tasks. If you choose rows 3 and 4 to read as your 20 words, then make sure you choose rows 3 and 4 for the subsequent tasks. Hopefully this all makes sense. Okay, choose your 2 or more rows right now, and then right after I finish saying this sentence, pause the video to stay on this page and time yourself, and then restart the video when you're done. Okay, so I chose rows 2 and 3 to read, and I timed myself, and it took me just a little over 8 seconds with no mistakes to read both rows. As I said, this simple reading task is going to be your baseline for the other things we do, so try to get a reasonably valid estimate. Okay, next we'll do the color naming task. You'll see that the layout is the same here, with 5 rows of 10 items each. And you'll probably notice that the color of all the items in this matrix corresponds to the color name that's in each location in the previous simple reading task matrix. You'll also notice that each item has the same number of X's in it as the number of letters that were in the previous page's words. So green has 5 X's, red has 3 X's, and blue has 4 X's. So for this task, all I want you to do is just name the color that the text of X's appears in for each item. Sort of like the reading task you just did, but without any word reading involved. Just color recognition and naming out loud. Make sure you use the same exact row or rows that you used in the previous reading task. So I'm going to name the colors for all the items in rows 2 and 3, going left to right for both rows, and I'll time myself again so I can compare it to the simple word reading task. Make sure you do this color naming for the exact same rows that you chose for the simple reading task that we just did. Are you ready? Okay. Again, right after I finish saying this sentence, pause the video to time yourself and then restart the video when you're done. All right. So this color naming task took me just a little bit longer. I finished with no mistakes in just under 9 seconds, so only about 1 second slower than the reading task took me. People vary quite a bit for this comparison, but I think the majority of people do color naming at about the same speed as they do for the simple reading task. I seem to be consistently a little bit slower with color naming. The interesting thing to note here is which task you're faster at. In the simple reading task, your brain has to process more individual elements than in the color naming task, right? Because in color naming, all of the letters are just X's repeated. But the two tasks involve the same number of letters in total. So if you're naming colors even a little slower than you're reading the words, that's already a sign that you have a highly automatized VWFA. We'll talk about this more after we've finished the other demos. Let's move on to the next one. Okay, now we're going to do the first part of the Stroop task, called the congruent task. This is called congruent because, as you'll notice, the words are all printed in letter colors that are consistent with the color name that the word itself spells out. The layout here is the same. Again, time yourself reading your chosen rows as quickly as you can out loud with no mistakes. If you make a mistake, start over and reset your timer. Are you ready? Again, right after I finish saying this sentence, pause the video to time yourself and then restart the video when you're done. Okay, I usually do this task just a little faster than I do the simple reading task, the first one we did without the color letters, and this time was no exception. I finished my 2 rows in under 7 seconds. I think it was about 6.8 seconds. This is pretty common, and it makes sense if you think about it. You should be able to do this at least as fast as you do the simple reading task without the added facilitation of the letter colors also priming your neural pathways. Some people don't get a noticeable improvement in speed for this task compared to the first task like I do. And that likely means your word recognition pathways are already maxed out for speed, even without color support. Occasionally, I've seen people experience a notable decrement in speed on this congruent color task as compared to reading with no color letters. And that's interesting. It seems to indicate an attentional interference effect from the information on color. All right, now let's do the most well-known part of the Stroop task itself, which is called the color word incongruent condition. As you can see, the layout is the same as always, but this time all the words that spell color names are printed in a letter color that is not the color name they spell. So that is, the word green is in red letters, the word blue is in green letters, and the word red is in blue lettering. So you can see how this is going to create an interference effect against the incredible automaticity that your word recognition system has. You're going to have to suppress the normal functioning of your extremely fast, efficient, and automatic visual word form area. Ignore what word the letters spell and instead attend to and name the color that the letters are printed in. Alrighty, same rules. Identify the same 2 or more rows you've been using. Time yourself. If you make any mistakes, start over and retime. Again, right after I finish saying this sentence, pause the video to time yourself and then restart the video when you're done with the task. So this is the Stroop interference effect. Pretty striking, right? This one is really difficult, and what's funny about it to me is that reading the words instead of naming the colors is so automatic that you often don't even realize you've made a bunch of mistakes along the way while you're doing it. So you might need a partner for this to keep you honest. My time for this incongruent task condition was about 15 seconds. That seemed kind of slow to me, so I did it a second time, and the second time took me almost exactly 15 seconds again. The Stroop interference effect is interesting for a whole bunch of reasons, and it's been studied a lot because it's been known about in psychological science for about 100 years. I think, if memory serves me, I think a guy named John Ridley Stroop was the first to characterize this in 1935. That sounds like a made-up name. I'll have to look that up. But it very potently demonstrates the incredible automaticity of our word form recognition systems, made possible in large part by a well-trained VWFA. One of the interesting points to me about the Stroop interference effect that you can see in yourself when you do this task is that worse performance on the incongruent task condition means that your VWFA is functioning especially well, right? So failing miserably means you have an especially effective, efficient, automatic, and highly specialized squiggle processing unit. In fact, I've used this phenomenon several times in clinical neuropsychological evaluations of kids who are in those early reading to learn ages. If a child shows no Stroop interference effect, then I can make a pretty informed recommendation to the parents about spending more time together looking at squiggles. Okay, I can't resist. There's one more word recognition demo that I'd like us to do. The reason I'm compelled to add this one is to show you that VWFA automaticity can actually boost your performance on a task that doesn't even require you to read. What do I mean by this? Check this out. There's another kind of cognitive effect that showcases VWFA called a word superiority effect. What I want you to do here is to time yourself looking for any letter R in all of the top 2 rows of words. So for each word, as quickly as you can, I want you to say out loud either yes if the word has an R in it, or no if the word does not have an R in it. Same rules. For this one, just the top 2 rows, as fast as you can with no mistakes. As usual, right after I finish saying this sentence, pause the video to time yourself doing this task, and then restart the video when you're done. Okay, this took me about 9 seconds. As you might have guessed, now I want you to do the same thing with the bottom 2 rows of the words. So next, look for the letter R in each word and time yourself just like you did with the top rows, but this time using the bottom 2 rows. Pause the video to do this now. All right, this one took me about 13 seconds. What's interesting here is that even when your cognitive task at hand is not to actually read the word, the automaticity of your visual word form system makes you faster at doing a related task. Essentially, your visual system is quickly connecting each word to its phonological or sound representation, basically its pronunciation. And this helps you more quickly determine whether the letter you seek is present or not, as compared to when you do this with letter strings that are unfamiliar and unpronounceable. One final word. I want to be absolutely clear that I'm totally not saying when you do these demo tasks or when you read, you're only using your visual word form area. Far from it. All of these tasks require the integrated combination of lots of different parts of your brain's functional organization. But it's the VWFA's powerful specialization, its speed and automaticity, that has come from lots of training and experience that instantly connects visual word forms to their associated sounds and meanings. As I said before, I think learning about the visual word form area is an excellent introduction to understanding how human brains work more generally. It's the perfect neurodevelopmental framework for thinking about how brains learn, develop, and function. Let me know in the comments how the demos went for you, or if you have any questions about any of this. Thanks for watching.